Hello everyone, a very warm welcome to Smiley Kids channel. Today we're going to see Class 10 Physics Chapter 10 Light, Reflection and Refraction. Topic Spherical Mirrors and its Components. So without getting late, let's get started. Let's have a basic view of the session. What are spherical mirrors? Followed by types of spherical mirrors. Then important terms related to spherical mirrors and ending with rules for construction images formed by spherical mirrors. So without getting late, let's begin. Firstly, what are spherical mirrors? A part of a hollow sphere whose inner or outer surface has been polished or silver is known as spherical mirror. This means if this is the sphere and I cut it in such a way that I get a hollow surface and I polish one of the side of this particular surface, this particular thing is known as a spherical mirror. There are two types of spherical mirrors, namely a concave and a convex mirror. In case of a concave mirror, the polishing or silvering is done on the mirror on the outer spherical surface, whereas in convex it is done on the inner surface. And in case of concave spherical mirror, the reflecting surface is inwards. And in case of convex, it is outwards. Now let's understand important terms related to spherical mirrors. First we have the center of curvature. Center of curvature is the center of the hollow sphere from which we have extracted the mirror. Well, yeah, the mirror is extracted from a sphere like this. And since we cut the sphere and we have obtained this particular mirror. So the center of this sphere is known as the center of the curvature and mirror is a part of this particular center of curvature. So yes, this is the center of the curvature for the concave mirror. And remember, this is the reflecting surface of concave mirror and this is the polished surface of the concave mirror. While what of the case of convex? This is the polished surface and this is the reflecting surface. In concave, we observe that the center of the curvature is in front of the mirror. That is, it is in the front of the reflecting surface. But whereas in convex, it is in the back side of the reflecting surface or back side of the mirror. Right? So the center of the curvature will be along this particular point. Because the mirror is extracted from a sphere like this, and the center of the sphere will give you the center of the curvature of convex mirror. Next term is pole, which is denoted by P, and previously center of curvature was denoted by C. Let's again say this is the center of the curvature of a sphere, and the same for the convex. Now, what is the pole? Pole is the midpoint of the mirror, and it is denoted by P. And this particular pole, which is denoted by P, is for the concave mirror. And what of convex? Well, yeah, it is the same for convex as well. It is in the midpoint of the mirror. This is the point P of convex mirror. Pole is the midpoint or the center of the reflecting surface of a spherical mirror. Now let's understand what is the radius of curvature, which is denoted by capital R. Well, yeah, this is the center of curvature and this is the pole of the mirror. Again, this is the center of curvature and this is the pole of the mirror, which is the same for concave and convex, right? Now, radius of curvature. Before we understand that, let's draw a circle like this and let's say this is the center of the circle, that is O, right? Now we know that when we join any line segment from the center of the circle to any point of the circumference, it forms the radius of the circle, isn't it? Exactly in the same way, the radius of the curvature is the path distance between P and C. This is termed as the radius of the curvature, which is denoted by capital R. And what of convex? Well, yeah, it is the same as that of concave, right? The distance between this P and C is termed as the radius of the curvature, which is denoted by capital R. Now, what is principal axis? Well, let's bring back our sphere again. And let's say this is center of curvature, pole, center of curvature and pole, right? And now this distance from P to C is the radius of curvature, same with the case of convex. Now, what is principal axis? If you have observed this white color line which has now become blue, this particular line where all the points are lying, that is the center of the curvature, pole, etc. are lying, this axis is known as the principal axis. And same with that of the convex, this particular line which has just turned yellow is known as the principal axis, where the center of the curvature, the pole and other components are lying. Now what is aperture? Well, let's bring back our sphere like this. This is C, this is P. The distance between P and C is termed as radius. Same with the case of the convex. This is C and this is P. The distance is termed as radius. And what is this line? This line is the principal axis, isn't it? Now, what is aperture right now? Let's consider one end of the mirror as A and the other end as B. Now let's eliminate the sphere and let's consider this as C and this as D. Now, what is aperture? The distance between A and B is termed as aperture. And here the distance between C and D is termed as aperture. This means the distance between the two extreme points of a spherical mirror is called the aperture. Now let's understand what is focus or the principal focus of the mirror. Well, yeah, this is the center of the curvature and this is the pole of the mirror, and same with that the case of the convex kind of mirror. And the distance between P and C is the radius of the curvature. Now, for understanding what is focus, we're going to incident a parallel ray which is parallel to the principal axis, let's say x and x dash, right? Which is reflecting back in this way. This is the incident ray and this is the reflecting ray. And let's say again I pass a parallel beam of light which is reflecting back in this way. And same with the case again of the third one. And what do we observe in common? They meet at this particular point. That is, there is a point of intersection at this particular point of the principal axis. And this particular point is termed as the focus of the mirror, and which is denoted by capital F. Now the distance between P and F, that is the pole of the mirror, and focus is the focal length. The distance between the pole and the focus is termed as the focal length, which is denoted by small letter f. Now let's understand this case with the convex mirror. I am incident in a ray like this, which is reflecting like this. Let's again incident a parallel beam of light which is parallel to the principal axis, which is reflecting in this way. And again like this and like this. Well, yeah. Do we observe any common point of intersection? Well, obviously not, but well, yeah. When I get these points all like this, backside of the mirror, I observe a common point of intersection, and this point of intersection is termed as the focus of the mirror, which is denoted by capital F. And remember, in the case of convex kind of mirror, the center of the curvature and the focus lie behind the mirror or behind the reflecting surface. And well, yeah, the distance between the focus and the pole is termed as the focal length of the mirror, which is denoted by capital, well, no, it's a small f. The capital F is for the focus of the mirror and small f is for the focal length of the mirror, that is the distance between P and F. This is all about principal focus of the mirror. Now let's recap all the concepts we have read till now. This is the center of the curvature, that is the center point of the sphere, right? And this is the pole of the mirror, that is the midpoint of the mirror. And there is a common point of intersection of all the beam rays which are parallel to the principal axis, and that point is termed as focus. And the distance between P and C is the radius of curvature, and the distance between P and F is the focal length of the mirror. Now, what about convex? Well, yeah, this is the center of curvature, this is the pole, and the common point of intersection behind the mirror is the focus. And the distance between P and C is termed as the radius of curvature, and the distance between F and P is termed as the focal length. Now we're going to see the relationship between the focal length and the radius. This is the center of curvature and this is the pole of the mirror. The distance between P and C is the radius of curvature, and we know that when all the light rays converge at a point, that particular point is known as the focus of the mirror. And it's very important to know that PF is equal to FC. That is, the distance between P and F and the distance between F and C is every time equal, right? So from this particular expression, we can derive R is equal to 2F. That means the radius of the curvature is equal to 2 times the focal length. We know that PF is the focal length of the mirror, right? and radius is PC. PC can also be written as PF plus FC, isn't it? Now what is PF? PF is the focal length, isn't it? And we also know that F is always the midpoint of P and C, that is PF will always be equal to FC. So FC can also be written as F only, right? Now PC is equal to F plus F, which is 2F. What is PC right now? It is the radius of curvature. So radius of curvature is 2F, isn't it? So the relationship between focal length and radius is that radius of curvature is equal to 2 times the focal length. Now let's understand the rules for constructing images spawned by the spherical mirrors. For that, let's bring back our spherical mirror. This is the polar surface and this is the reflecting surface. I hope you all know this. And well, yeah. Now we're going to draw the principal axis. That is an imaginary line where all the components lie, isn't it? Like the center of the curvature, which is here, and the pole of the mirror, which is actually the midpoint of the mirror. Now the midpoint of C and P will be F, which is the focus of the mirror, isn't it? Now rule number 1 says that whenever a parallel ray which is incidenting on the spherical mirror after reflection passes through a point called focus, that is whenever an incident ray is striking the mirror and is reflecting back, it is definitely sure that it will pass through principal focus or the focus. Now what is rule number 2? Well, rule number 2 is very easy. It is exact opposite of rule number 1. This is a spherical mirror and this is the principal axis where center of curvature and focus lie. And this is the pole of the mirror, which is the midpoint of the mirror, isn't it? Now, rule number 2 says that an incident ray which is passing through the principal focus. Let's say this is the incident ray which is passing through the principal focus. When reflected, becomes parallel to the principal axis. This means that whenever we are incidenting a ray, let's suppose say, I'll explain it again. If suppose I'm incidenting a ray which is passing through the focus, this means when it undergoes reflection, it will be parallel to the principal axis, isn't it? This is the principal axis and let's say this is the reflected ray A, and A will always be parallel to X. It is the exact opposite of rule number 1. Now rule number 3. Let's bring back our spherical mirror. This is center of curvature, this is the pole of mirror and this is the focus. Now rule number 3 says that whenever a ray is incidenting through the center of the curvature and it strikes the surface, that is whenever a ray which is incidenting or passing through the center of curvature, when reflected, it reflects back along the same path, that is it reflects back or retraces its path back along C only. And here it's very necessary to note down that angle of incidence is 0. When angle of incidence is 0, we know that angle of incidence is always equal to angle of reflection. So angle of reflection will also be 0. Now what is rule number 4? This is our mirror. And this is the principal axis. This is the center of curvature. This is the focus and this is the pole of the mirror. In the previous 3 rules, we have seen all about the center of curvature and focus. Now what is the thing which is left out? Well, yeah, it is the pole of the mirror. What happens to the light ray when it strikes the pole and makes the reflection? That is what we're going to see in rule number 4. When a ray of light strikes the pole, this is the incident ray, right? When this incident ray strikes the pole, when reflected back, it makes an angle with the principal axis, isn't it? Well, yeah. So after reflection, it goes on the another side of the principal axis. This is the first side of principal axis and this is the second side of principal axis, isn't it? And this particular angle which it is making with the principal axis, let's say, is angle x, and this angle which is making after the reflection, let's say it is y. This here means angle of x is always equal to angle of y. This is what rule number 4 says, because it is obeying the laws of reflection, which means angle of incidence is always equal to angle of reflection. Basically, it means that the fourth rule says that a ray of light which is incidenting at the pole makes an angle with the principal axis. After reflection goes on another side of the principal axis, making the same angle. Now let's have a quick recap of what we have learned, because all these important rules are very necessary for the ray diagrams which we're going to do in next video. So this is a spherical mirror and this is the principal axis. This is the center of curvature, focus and the pole. Now what does rule number 1 say? Rule number 1 says that a ray which is parallel to principal axis reflects back and passes through a point called focus. Isn't it? That is rule number 1, where the incident ray when striking the surface reflects back and passes through the focus. Now what does rule number 2 says? Rule number 2 says that a ray which is passing through the focus, well, let's say this is a ray which is passing through the focus, when strike the surface reflects back, and it reflects back in such a way that it is parallel to the principal axis, which is the exact opposite of rule number 1. This means whenever a ray which is passing through the focus strikes the mirror, it reflects back in such a way that it is parallel to the principal axis. Then rule number 3 says that whenever a line which is passing through the center of the curvature, which is incidenting the surface of the mirror and reflecting back, it reflects back in the same path, or it retraces its path back. This is rule number 3. That is, whenever an incident ray strikes the surface which is passing from the center of curvature, it reflects back along the same path, that is, it passes again from the same center of curvature. Isn't it? That is rule number 3. Now what of rule number 4? Whenever a ray which is striking the pole, whenever an incident ray is striking the pole, when reflected, it reflects on the other side of the principal axis. It reflects on the other side of the principal axis. And now if you observe, the angle of incidence is being made with the principal axis. Let's say this is angle x and this is angle y, which is made by the reflected ray. This means it makes the same angles, that is angle x is equal to angle y, obeying the laws of reflection, that is angle of incidence is always equal to angle of reflection. This is nothing but a ray of light incident at the pole and making an angle with the principal axis. After reflection goes on the other side of the principal axis, making the same angle with the principal axis, obeying the laws of reflection, that is angle of incidence is always equal to angle of reflection. Here we have come to an extreme end of the session. For more such updates, please subscribe our channel and hit the bell icon for all the updates. Thank you so much.